and we were shocked. The people with Alzheimer's disease had pretty much no carotenoids. No. All regulatory, I'm so happy you asked this, because all regulatory around food supplements is connected to labeling. And oxidative stress, in my view, is the beginning of every sickness we have in our body. I will tell you that 70% of those carotenoid supplements will not have active material that you're paying for. You know, so industries will put pressure on scientists to publish in those predatory journals, and they publish anything. So peer-reviewed science, unfortunately, is becoming contaminated too. Get the notion out of your head that cholesterol is bad. We'd be dead without cholesterol. Calculated that about 86,000 people in Ireland have some form of macular degeneration. Eggs are a wonderful food factor.
Professor John Nolan, thank you so much for joining me. I'm really looking forward to the opportunity to speak with you. Today we're going to talk about nutrition. And it's undoubtedly, looking into your work and your background, you're a noted expert on the field. So I want to get your advice, your thoughts, your perspective. And once again, thank you so much for joining me.
It's a pleasure. Yeah, happy to have a conversation, and maybe we can learn together.
Okay, so let's start with your background. What drew you? Why nutrition, John?
Wow. Look, the honest answer is, I suppose I was going to say the honest answer is I didn't know what to do when I finished school, like everyone, and I wanted to do sports science. And I've recently actually gone back to my school to speak to the kids getting ready for their finish their leaving cert, and they're all terrified and they think that they should know. And now more than ever, mammies and daddies want little Johnny to go and be a doctor or a scientist or a dentist or whatever. And the reality is little Johnny doesn't have a clue, and mammy shouldn't. So I got very lucky in that I had a mom and dad that were not career driven. They wanted me to be successful, but they supported me. And that kind of allowed me, you know, deliver upon an opportunity, which was I studied science, and I was less than average in school. Really struggled in school, didn't really understand how I wanted to know everything, and I worked so hard, but I when I was reading words or studying science, I was studying it to learn it and not to understand it. And that was the one thing that changed. I went to then WIT, and that was really suited me because it was kind of a very practical approach to learning. There was a lot of practical science classes, and I started to understand science, and I just kind of fell in love with science at that point. And I taught my class most years. And so the working hard bit paid off because I was figured out that I was interested in science. And I would say my primary interest is human function. And I love biology and I love biochemistry as part of my own science degree. And then when I finished my degree, I had an opportunity to work work with microbiology laboratories and biochemistry laboratories. And I did a bit of that, but there was a PhD program that came up. It was actually funded by Fighting Blindness Ireland, and a very well-known lady, a wonderful human being called Maya Doherty, who set up the river dance, as you know. She had a strong interest in a disease called macular degeneration, and she wanted some research done. So basically she made a grant available, and there was a scholarship offered through my university, or through then the Institute of Technology. And I applied for that because it was working with people. It was kind of profiling people about their risk for macular degeneration. And then the question was, well, what is this disease of the eye, of the back of the eye, which we might talk about today a little bit. And, you know, can we do something to help those people? Are there risk factors that are modifiable? And that's what got me to nutrition, because the established risk factors for that disease, macular degeneration, are genetics, which you can't change. today anyway. We can change future genetics. Age, cigarette smoking was a big one, so that was a modifiable, and nutrition was kind of, people thought it might be interesting. And when I basically ran a major program, I worked with over 1,000 people randomly selected from the population, and I essentially profiled them, and I saw, based on their risk factors, I was able to characterize them. So for example, Connor, might be significant percentage of people with that smoke cigarettes or that had a known family history of macular degeneration. So they'd be in a high risk group. And I started measuring nutrition. And then I started to learn about, actually, when we talk about nutrition in the context of this disease, are there nutrients in the eye? And remarkably, there are nutrients, micronutrients in the eye. And these micronutrients are nutrients called carotenoids, which we can talk about today a little bit. So I kind of funneled my interests within nutrition very quickly into connecting it back to that disease. And that's where everything started, because we knew all these risk factors, but I was the first person, I suppose, in the world to measure this pigment in the eye, this nutritional pigment in the eye. And what we found essentially was that this pigment was highly correlated and connected to those established risk factors. So in other words, the human beings in Ireland that are walking around, they've no eye disease today, but mommy and daddy might have macular degeneration, or they might be high cigarette smokers, or they may have been in that older section of the population. Those individuals had really low amounts of this pigment in the eye. So it was closed the link and the loop between the disease, the risk factors, and this pigment, which I've basically spent 25 years studying and working. And that's kind of why I'm really focused and interested in nutrition and human function. And then that led us on to nutrition and the similar activities of those micronutrients for eye health, brain health, cardiometabolic disease, potentially everything.
I was thinking about when you were talking about the incredible, the depth and the length of research that you've been doing, is how much does lifestyle influence macular degeneration? And can we parse lifestyle from the genetic hereditary piece, right? What's your perspective there?
Yeah, I think the obvious answer is probably not the correct one. And I think that's unfortunate. I think, like, I'd love to sit here and say the healthiest person listening to your podcast won't get macular degeneration. There's a chance they will. So the way I would look at it is that, you know, the genetics are the predispose you to disease. So they determine whether you're highly likely or not likely to get the disease. But what kind of activates the genetics, if you like, what turns it on and off, is the lifestyle. So it's major. So negative in the first part of my answer, that, oh, even if you're good, you could be in trouble, which is true. But if you think of it as kind of a line, and just think of that line as age, and this, let's just say this is 100, so the top of the line versus when we're born. And let's just say my genetics say I'm supposed to get macular degeneration at age of 60 because I have the bad genes, and we know what they are. They're ARMS2, complement factor H. So basically, we know the genes that people have when they more often get this disease than don't. So let's just say John Nolan has those bad genes. So, but here's the thing, here's the opportunity. If I optimize my lifestyle, even though I'm in trouble because I have the bad genes, and I don't smoke, and I enrich the nutrients, which I'll tell you about today, and if I protect my eyes from sunlight and all of the things, the risk factors, if I optimize all of that piece, I'll push out the age at which I'm going to get the disease. And that's the opportunity. Okay, so lifestyle is crucial. It works the other way too, Connor. Like if I'm a good lucky and I don't have the bad genes, we still see people with macular degeneration who don't have the bad genes and don't have a family history. Why? Because they smoke too many cigarettes. They have no carotenoids in their nutrition. They might continuously expose themselves to wavelengths of light that are damaging. They might be totally overweight. Weight is a big one. And obesity is a big one because, and it's simple, it's not complicated. It's a big one because if you think of fat as a competitor for micronutrients, and for me, really the most powerful micronutrients in our biology, in our biological system, are what we call fat soluble. And therefore they go into fat. So in other words, if I was double the size I am now, I would have double the competition to absorb, take up those micronutrients. So I'm going to need more and more and more. And we know with weight gain and obesity that the more and more and more food that people eat certainly are not the foods that contain the micronutrients that we need. So that's a double negative. So lifestyle is crucially important, but there's so much that we don't know. I mean, when I look at my own PhD, which is on the wall here beside me, published in 2005, 20 years ago now nearly, that showed we were able to, it was called determinants of macular pigment. So the macula is that center part of if you think of the eye like a camera, and the back of the eye has the film of the camera. That's your retina. Okay, and just like a camera, the front of your eye, the lens. So there's crucially important parts to the eye. But the magic happens in the film of the camera, and the magic happens in the retina. So we want all of this light to come through the front of our eye. It gets sent to the back of our eye. We call these photoreceptors. So they capture that light. And in a perfectly working camera, the film is nice and perfect. It's able to work, and in perfectly working human vision, the retina is healthy. All the photoreceptors receive that light, electrical transmission to the brain. We see everything. But to get to the point, the very center of the macula, of the retina rather, is an area known as the macula. And it's only about 4% of the entire retina. And it's responsible for over 90% of our vision. So it's all kind of the magic, I say, happens right there. And these nutrients, these macular pigments, which I speak about, are concentrated there. So, and then the question was, well, okay, we have this tissue at the back of the eye, this light-sensitive specialized tissue that gives us vision. We know with age that can get sick, can become degenerated, hence the name age-related macular degeneration. It's the macula. And we accept it because we call it a function of aging. And it is. And we know why it happens, and I can tell you about that in a minute if you like. But the point is, it happens, but we can solve it with nutrition. And that's connected to lifestyle and dietary habits. So in other words, I can, with nutrition, put an antioxidant, like as a sunscreen, if you like, right at that specialized piece of the eye that has the following properties. It is an antioxidant, just like sunscreen, but it's concentrated and located there. And it also filters light. And look, not to get too sciencey, or maybe you want to go a little deep on it, but basically, if you think of the light spectrum, you have ultraviolet light, which is what gives us sunburn. You have the visible light, which are essentially the colors of the rainbow, visible light spectrum. Now, it's important to tell you this. Ultraviolet light doesn't get to the back of the eye. And ultraviolet light has really high energy. That's why we get sunburn from the sun. But the retina and our macula has to use and process visible light. And within the visible light piece, the shorter wavelength, the blue light, can be problematic because that also has high energy. And that causes what we call photo-oxidative stress. And maybe your listeners maybe you spoke about oxidative stress before, have you? Would you like me to speak a little bit about oxidative stress? Or
I'd like to know. I've heard you speak about it, but I don't think my listeners would know what you're.
Yeah, sure. So it's not that complicated. Okay. So basically, I'll summarize this again because there's a few pieces to it, but it's okay. So basically, again, the job of the macula is to receive the light. In an ideal world, it processes that light. The macula can get sick. Why does it get sick? It gets sick for a couple of reasons. One is caused by oxidative stress. And oxidative stress is simply caused by molecules that are produced as we use oxygen in that part of the eye. So for the eye to stay alive, to function, for the cells to replace themselves, divide and so on, and they use oxygen. The byproduct, the cost of being alive, is a production of what we call a free radical. And a free radical is simply an atom that's just missing an electron. So what it will do is say, oh, I want to take an electron from the healthy cell in the back of the eye, and it steals it. And it's a negative thing to happen. So we need an antioxidant protective mechanism at the back of the eye, which we have over our life and kind of enough to deal with those living stresses. I mean, oxidative stress is not a bad thing. It means we're alive. But if we have too much of it and too little defense, our cells and our tissues can get sick. And oxidative stress, in my view, is the beginning of every sickness we have in our body. And here's the wonderful thing. Nutrition and targeted nutrients that have antioxidant properties can reduce or even prevent that happening at all. So we can put an antioxidant via nutrition, via these carotenoids, which we should talk about. And then the last thing this pigment can do, these pigments, is they can filter light. So because they're yellow, the yellow pigment, that's why the pigment that I study is called a macular pigment, but it's also called macula lutea, which is Latin for yellow spot. So it's the yellow spot in the back of the eye. And it's yellow because these nutrients, which we get from the foods we eat, are yellow, and they come into our body and they get transported from the stomach to the lymph system, blood system, transported to the back of the eye, and we have these binding proteins. And in a healthy individual at low risk of macular degeneration, we have plenty of this stuff. But as we age, that becomes more and more of a problem, and therefore we need to find ways to enrich and optimize it.
But John, can I just jump in? Quick question there. There's two things I wanted to ask you about. First of all, the statement that oxidative stress is the source. I mean, how disputed is that? How big of a statement are we talking here?
Okay. So it's not, it can't be disputed scientifically because it's a scientific fact. But here's where I'll get direct. Okay. Medicine doesn't deal with oxidative stress because medicine deals with the next stage of the process. Oxidative stress causes an inflammation. Medicine deals with inflammation, and that's where pharmaceutical comes in. So I always use the analogy of my daughter Penny and B, my daughters, and when I'm teaching about this, I say the oxidative stress is the equivalent of Penny and B falling off their swing set. So the impact, the trauma is the fall, the impact onto the floor. What happens after that is the bleeding, the swollen knee, the inflammatory response to try and fix the problem. And the exact same thing happens in macular degeneration. So when I look at an eye, a 50-year-old eye, I can see disease. They call it age changes, but it's basically disease, the start of the disease. And in retinal medical ophthalmology, they call these drusen and pigmentary changes. So they're just changes that are not there when you're born. And there's something that happened when we get older, or if we have all these risk factors, we start to see these drusen. And that's basically the result of oxidative stress. And all that happens, Connor, is that the eye starts to get sick. And when it starts to get sick, the normal cleaning process from the RB system is broken down. So we can't clean up. We can't recycle. We can't clean. And you get these clogs called drusen, lipid deposits called drusen. And then that happens and happens and happens. And then we have this massive trauma that is an inflammatory response. And that's where in the disease macular degeneration, they call that portal neovascularization, which is basically blood vessels rush into that part of the eye, covering over it, trying to fix that sick part of the eye. And that's where medicine gets involved. They actually wait till we're there to say, okay, you need to go to the hospital now and you're going to inject Nanny 20 times a year with a pharmaceutical drug that either costs the insurance company or the patient $2,000 per injection per eye.
Yeah.
Now, are those treatments good? Wonderful, because for people who have had this life trauma of getting to that end stage of disease that they call it the wet form or the neovascularization form. That's one of the most traumatic things can happen to a human being, right? It's probably, when you do the surveys, losing your vision is the most frightful thing for any human being. It's up
It's
there.
like a devastating impact on quality of life, on everything. And the
So,
trauma of losing it slowly as well.
oh, the fear of
Mm.
it. And, you know, I have a phone message from a patient, a 93-year-old lady who called me from her bed, who listened to me on her. I was going to Donegal to do a lecture, and they promoted the lecture. And I did an interview with the radio station, and it was just a very nice conversation. I told them what I was going to be speaking about, and the lady was listening, and she rang me. And I didn't get her message, and I've got back to her since, but the message that she left me says everything about how traumatic this is on a human being. Anyway, the point is, the question was, you know, how everything starts with oxidative stress. Yeah, so I think it's the same in the cardiovascular system, right? So we are in the brain. You know, inflammation of the brain is connected to Alzheimer's disease. We talk about plaques in the brain. We talk about plaques in our vascular system. So what is that? It's oxidative stress and we've just published a major paper on this, actually. Nicole Stringham, a brilliant scientist, and Marina Green's PhD, the collaborative work.
I'll put a link to it in the description for anybody that's interested in on YouTube and on Spotify and on Apple as well. One thing, when we were talking about the work, what I was hearing, John, is that we can delay the onset of macular degeneration with the right lifestyle and the right nutrition. Are you saying the right nutrition and the right lifestyle can have a remedial effect and reverse?
Yeah. I mean, let's not over sensationalize it, and with respect to the people that are suffering with these conditions, I want to sober up that comment a little bit. But have we seen wonderful? I like to talk about function as opposed to morphology. Morphology being the disease itself.
Mm-hmm.
So can we deal with the symptoms? That I'm sure of. So for someone who has the disease, if we enhance their antioxidant defenses with micronutrition of the eye, can we make them see better? Yes, that I'm sure of. It's not a silver bullet for the disease. The disease is there. Equally, when you have the pharmaceutical agents, the disease is still there. They're just cleaning up the leaking blood vessels. But where the real win could be and should be, and what the data shows us, there's a biologically plausible rationale, and now we have a body of evidence that's just so concrete, that if we were to intervene much earlier, we would stop it happening in the first place. That's kind of the win. So I call this, I'm talking about it quite a lot lately, I call Health 3.0, which is preventative nutrition.
Can you describe what that early intervention looks like?
Yeah, it doesn't look like eating a plate of vegetables.
I was gonna say broccoli and kale, yeah. but
so if I was to show you my garden now, I'm growing broccoli and I'm growing spinach and I'm growing all of those things, because what we really want to happen, and which is not something I can achieve or this podcast can achieve, is that we, from schools all the way through our life, that we just do significantly better with plant nutrition. That's a big vision, and that's something that we should not lose sight of, no pun intended. But what I do a lot of work with supplements, and the reason why I do a lot of work with supplements is, if you think about it, I think if you go to a medical professional of any discipline, and if the outcome, typically they feel they have to say, improve your lifestyle and eat well. And I say, wow, how useless is that information? Because how does anybody know what that is, and how does anybody comply to that? I hope your listeners don't say that John Nolan's saying we don't need to do that. We do. Please do. Okay. But I'm just saying, it's kind of very hard to comply to, particularly if you're moving through your life and we're getting to a stage where our risk factors are taking over and we have the bad genetics and da. So what I kind of say now is, why would we not? What's good about the good nutrients? It's not the fibers or the protein. They're good because we need fiber and protein. And I'm not an expert in that space. So there's certain foods that give us protein. There's certain foods that give us energy. There's certain foods, and so on and so forth. My area of knowledge is around what particular micronutrients that live in those foods can do. And that's why the supplements are important, because when I started my research, so I've already told your listeners about and viewers about, nutrients of the eye. So let me tell you what they are, and then I'll tell you why supplements are a wonderful solution. So they are called carotenoids, and carotenoids are plant-based micronutrients. So they're in plants. They're the colors that you see in all the fruits and vegetables are in plants. The colors of bird feathers, the colors of fish skin. Any natural color is because of this nutrient called a carotenoid. Now, a carotenoid is interesting because it's not a vitamin or it's not a mineral, but it's basically a lipid-like compound. So it lives in plants. And the reason why carotenoids are in plants are to protect plants when they're growing in photosynthesis. So to help them deal with light. So that's kind of interesting. There's about 700 carotenoids in nature that we know of, 700 plus. And, examples would be tomatoes have lycopene, so which we know is good for prostate cancer. A lot of evidence there. Beta carotene is another carotenoid present in, also in tomatoes, but carrots, of course. In our diet, we're consuming about 50 of these. In our blood system, which is our delivery system, our taxi system, we transport about 15, and isomers maybe 20, depending on what you eat determines what's in your biological transportation system. But what has me stuck on the eye is that we have 3 of them in the eye. And your listeners or viewers will probably not remember the names of these, but they're lutein, which is commonly known maybe. There's one called zeaxanthin, and there's a unique carotenoid called mesozeaxanthin. And you mentioned broccoli. Broccoli is a great source of lutein. Eggs are a wonderful food factory. We should talk about eggs maybe a little bit. I'm a big fan of eggs, and I'm a big fan of cholesterol. So come back to that. And mesozeaxanthin. And so the point is that out of the 700 carotenoids that are in nature, we've evolved to accumulate 3 of them at the little tissue that gives us vision. And that's wonderful knowledge to have. And then I suppose our science was to figure out, Connor, well, what are they? Do we have enough of them? What happens if we increase them? Who is deficient, and so on? And that's really what the 25 years of science at my laboratory has been about. And our methodology to understand and test that has been the wonderful experience we've had working with what we call volunteers, human participants, human subjects, we call them in clinical studies that we do. And we've worked with everyone from children in schools all the way through to people, unfortunately, dying with Alzheimer's disease. So we've looked across the spectrum of population to understand, and we've learned so much. But here's the point. I could say to you, Connor, if you eat spinach and kale and peppers and corn and eggs, that's great. You should do it, and that'll increase your lutein and so on. But what if I was to tell you that we actually found a way to really concentrate them into I have a small, yeah, I have it here actually. I'll show you an example. So maybe you can see this. So there's a capsule. So that's one capsule. And this has an average diet that you and I are probably consuming. It has about 1.5 milligrams of carotenoid. This has 22 milligrams of carotenoid in this. And it's the exact carotenoids that go into your stomach, that go into your blood, and will be transported to the binding proteins in the back of your eye. And that's where lutein, zeaxanthin, and a really crucial carotenoid called mesozeaxanthin is found. And they form this protective macular pigment. So in other words, from this, I can get 20 times more than what I'm per day than what I'm getting from even a normal diet. And it can't hurt me. There's no side effects, there's no toxicities, there's no contraindications. It's basically it comes from marigold petals. So we work with an organization here at our university in Mexico, an organization called Industrial Organica, and they're one of the organizations that produce carotenoids. Originally, they did it for hens to make the egg yolk yellow. But as the human biology evolved, they started to provide high quality, pure formulations. So I started working with my Mexican colleagues maybe 20 years ago now, and everything from optimizing the amount of the carotenoids there, getting enough of this very special mesozeaxanthin in, and it's that unique formulation that we've been able to test. So I hope, like, I haven't said don't be healthy and don't do the right things with food. Please do.
No.
That's the pillar of health. But if you want to do business with macular pigment, we have a really good way to do it. And I spoke to the government about this, because if you look at Ireland, we've worked with, we profiled via the Irish Longitudinal Study on Aging, a wonderful program run by Professor Roseanne Kenny and her team out of Trinity. The TILDA study, you've probably heard of the TILDA study. It's basically a study in Ireland where we're getting ready for the growing and aging population. And I believe the insurance companies are involved and philanthropy and everyone's involved, which is great because you need support to do that type of research. But I was very fortunate with my colleagues to get to work on the eye part of that in the early stages. And we profiled, there was 5,000 odd people assessed from Ireland, and we calculated that about 86,000 people in Ireland have some form of macular degeneration. But only 0.3% of those will be eligible for that pharmaceutical treatment. Everyone else is left to their own devices. And we did a cost benefit assessment. In other words, if we were to provide these supplements to everyone that had some form of macular degeneration, we could save the Irish government 300 million over 5 years.
In the remedial post disease.
And in that case,
yeah.
Even in that.
Let me, so, okay, that's a fantastic, so this is pre-disease. Taking these supplements can delay the onset and actually improve your quality of life, and probably, will it affect, is there a link then to cognitive decline and Alzheimer's as well?
Yeah, great question. Yeah, so when we did about 10 years work with eyes, and basically what we were trying to do for the most part was figure out how to measure what we were interested in. That's what scientists do. And your science is as good as your measurements, right? So we spent a long time doing that. And then we published some major papers and all these PhDs and everything were happening. So we really felt we had kind of discovered, we had some what we'd call exploratory data, where we added in, where we identified that there was this kind of profile of people that had a kind of a dip in this protective pigment, which was a bad thing, because if you think of having it being good, you kind of want that mountain of protection and not a volcano. And long story short, I hypothesized that that dip was due to a deficiency in a carotenoid called mesozeaxanthin. And that's basically a carotenoid that's not normally found in the diet, but yet if you chop up an eye and look at it, it's the most concentrated one centrally. So we believed, the biology suggested, the chemistry suggested that when you eat lutein, that carotenoid is converted in the body into this wonderful, powerful antioxidant. But what was really interesting was about 12% of the population that I studied had this and not this. And they were the people who had all those risk factors for macular degeneration. So I said, God, what if we give them mesozeaxanthin in addition to lutein? And we did. And we found that we were able to do this. But when we gave them lutein only, it stayed there. So that was a discovery for me. And there was other scientists doing wonderful work showing that actually, if you were to take this capsule and if it was just all lutein, which is one of the most used carotenoids for macular degeneration, it would be very good, but the antioxidant benefits went up through the sky when they were working together. So we had lots of other scientists. Anyway, to answer your question on cognitive, I tell you this because as part of a major grant from the European Research Council, an NRCI grant, which is a lottery grant essentially, they challenged me to look at what they call new horizons. So then we had to think, well, what else can we do beyond our lane of like vision and macular degeneration? So the retina is part of the brain. It's the seeing part of the brain, right? So the brain and it's connected, and this is by design and by extension. We can look at the brain actually by looking into the eye, which is wonderful. So I said, well, what if what we're doing in the eye has significance for what's going on in the brain? And there was a wonderful scientist from America, Liz Johnson, who was working along the same lines, and she actually did a centenarian study and measured the same pigments that I'm interested in, and those wonderful human beings donated their brains. And when Professor Johnson analyzed the brains, she found that the carotenoids that were in the macula that we can measure in a living person correlated with what's going on in the brain. And in the exact same time, I was measuring as part of the TILDA study, macular pigment, and there was another scientist called Joanne Feeney and Roseanne Kenny's team. They were measuring cognitive functions. And I was publishing all the work on vision and nutrition and carotenoids, and they were publishing all their cognitive function work. So we had this really rich data set of 5,000 people where we had these parameters, and we said, let's look at it. And remarkable. Observational, cross-sectional, which means that just taking a snapshot, we saw that the human beings that we measured that had high macular pigments, high pigments in their eye, had much better cognitive functions, much better cognitive functions, like memory, attention, reaction time, all these things we can measure in the living person. And I said, wow, we're really onto something. So adding that to Liz Johnson's work and what we were doing, that was just so exciting. And then I partnered with a wonderful doctor here in Waterford called Professor Rena Mulcahy, he was a geriatrician. She just loves her patients as a primary. You know, her most important is minding her patients and doing the right thing by her patients. So, but she was very interested in lifestyle and nutrition. And so we started to talk, and she was very interested to help me try and see, could we learn with the disease, Alzheimer's disease. And we did what's called an exploratory study. We measured macular pigments, we measured vision, we measured carotenoids, and we were shocked. The people with Alzheimer's disease had pretty much no carotenoids, none. And you may say, well, what do you expect? Carotenoids are entirely of dietary origin. If you're not eating them, you don't have them. So then we had to see, well, if we gave them, could we improve? And we did, and they did. They improved in their macular pigments, but we didn't enhance their cognitive functions in the early work we did. So we studied the brain in more detail, and you will know that, you know, brain is major fat, you know, it's made up of fats. And you probably hear of omega-3 as being you know, from fish oil. DHA is one of the most dominant omega-3 fatty acids in the brain. So we were interested to see then if we added the carotenoids to the omega in this, could we get a better result? And we did. And we spent a long time doing two things. A, trying to get high enough DHA, because you need a good bit to change, again, throughout your biological systems. So we worked with colleagues in Norway to do that, who specialize in omega-3 production. And we combined the ideas, and the results were outstanding. And I was really excited. And I remember it wasn't at that time like what you would consider a gold standard trial. You know, in research, you can do kind of exploratory work where you don't make it double blind. And what I mean by that is that, you know, I knew what I was given the the patient. So that's a limitation of the study.
So
But
the bias could be
yeah,
further injected into the process. And if you have double blind, then you're removing the possibility of bias.
yeah.
And it's placebo controlled as well. I think, yeah.
So we scaled up to that because we told the world about it before we did that. And I remember going to the UK, giving a presentation, and the media were there, and I had a wonderful response. And then I had a very negative response,
Because there was critique of your methods. Was there a critique of?
correct. Yeah, which I accepted. And so Professor Mulcahy and I went back and we did the biggest study we could do in a proper design, and we refined our methodologies. And this was supported by a foundation in the UK called the Howard Foundation, and they helped us do it. But again, we did it, and the results were remarkable again, and we learned even more this time. We were able to enhance. Our main outcome measure was progression of disease, but there was, just like vision, you can't just look at one parameter outcome. You have to look at the whole clinical collateral, the whole package of outcomes. But we saw very clearly that people still had the disease, of course. You don't get rid of a disease with a supplement, but were we able to support their lifestyle and their functions living with disease? That's what we were interested in. And what the data showed us very clearly, compared to placebo, the Alzheimer's patients, now these were Alzheimer's patients that were mild to moderate, so they weren't advanced, they were mild to moderate, but the effects were very, very significant on those compared to placebo, which was great. And particularly around mood. And
I was just about to ask you about the link with mental health and depression, anxiety, and the lack of carotenoids. Are you aware of any studies, John?
And not done by me, for wonderful scientists from America, Jim Stringham, Liz Johnson, not Liz Johnson, Randy Hammond, Lisa Renzi, all these scientists in the US they work with college students. There's a direct effect on even lowering, cortisol. It's not my area, but I'm, looking at it, we see effects, and we've just published on reducing measures of inflammation in the blood system. And actually, going back to my first point on oxidative stress, right? So the reason why we get plaques, why we get these issues, is that if you think of it, so LDL, which is part of your cholesterol, if you're unhealthy, you have more LDL than HDL, right? So your listeners might be familiar with the ratio importance of cholesterol. You want high HDL and low LDL. But look, we're always going to have some LDL. And over time, your LDL can get oxidized. And what happens when the LDL gets oxidized in the body, the cleaning system, which is basically when the body says, oh, we have something to clean up, they send out the macrophages to gobble it up. But what can happen is if you're over-compromised, your LDLs can form what we call foam cells, and they're foam. And then the cleaning system gets clogged, stuck. And then the body, what does it do? It calcifies over it. And that's where narrow. That's a plaque. So what we've shown is that with carotenoids, we can get in front of all of that, just like in the eye, and same in the blood. And I think that's really, really... Now we need to do more work on... I'm not an expert in cardiometabolic disease.
Let's just... So for ordinary people going about their everyday lives, you're suggesting an early intervention, very early, with carotenoid, with supplements.
Yeah.
Lifestyle changes. Okay, we're saying the obvious ones: alcohol, cigarettes, etc. Can sleep affect or impact carotenoids production in any way? Or
so sleep is... I've just started working with a professor, Rico. He's just joined our center, supporting us. He's actually his previous work with the All Black Sevens rugby team, performance, and his specialty is sleep. And we're co-supervising a project out of Singapore. Actually, we have athletes getting ready for the Olympics in the next few months. And there's a PhD student from our center, Parim, working there. And one of her outcome measures is sleep, for the exact reason you ask. So I'm not an expert in sleep. It's something, personally, I definitely don't get enough of. and some by my own fault and some just by the life I live, something I want to improve on. But I think I'm happy and looking forward to learn about the connection between nutrition. There's already some data connecting like omega-3 and sleep patterns. So Rico is testing this with us, both for the athletes, but we'll be scaling that into a major sleep experiment that we're planning to do in the future. So maybe the topic of a future discussion.
Yeah. And let me just reiterate there, John, the vegetables that you're saying that are high in carotenoids, right? We're saying kale, we're saying the leafy greens, right?
Yeah, leafy greens. And the only reason why greens are not colorful is because of chlorophyll. It covers if you take away the chlorophyll, which we can do, you see all the wonderful colors even in spinach. It's remarkable. You often see it in a plant, it goes kind of yellow. You see when it loses, so it's losing its chlorophyll. So you can see the carotenoids. Well, anyway, to answer your question, in Ireland, it's peas. Number one intake of lutein is peas. We eat a lot of peas. Corn. My daughter is brilliant at eating corn. And it's something we're doing a project with schools at the minute, trying to help and promote healthy eating in schools. And I think, 5-year-olds can take a tub of corn to school, and it's sweet, it's tasty, it's great source. Eggs, definitely eggs.
So we're big fans of eggs, right?
I am.
Is there a limit on how much?
No.
I mean, would you be no? Just keep going.
No, I mean, I see some of the muscle builders and they're swallowing eggs, and I'm not into that. But I honestly think, Connor, you could eat 2-3 eggs a day and have no negative health implications.
Only positive.
Your cholesterol will go up, but your HDL goes up, your LDL comes down. And for your viewers' benefit, cholesterol, get the notion out of your head that cholesterol is bad. We'd be dead without cholesterol. It's essential. It's what transports fat-soluble micronutrients throughout our biological systems. It's crucial. So cholesterol is great. Eggs are wonderful. And I'll tell you why eggs are wonderful in the context of carotenoids. They're a carotenoid factory because bioavailability, which means our ability, and bioaccessibility, our ability to break down and use the nutrients from, like if you eat a raw carrot or peppers, you're going to get very little, if any, micronutrients. It's going to go through your system and out where we know it goes. So carotenoids are really, really wonderful, but they're very difficult to do business with because if they're even in a supplement, if it's not formulated correctly, it'll die. When it's in our body, so you have two types of these type of micronutrients. You have water soluble and fat soluble. So water soluble is your vitamin C, and that's why we've all taken a vitamin C, and then you see your urine is excessively yellow. That means we haven't used it all. We probably saturated our transporters, done fine. But carotenoids, you don't see them in the weed. They come out the other way because they're fat soluble. But if you take a carotenoid in plants and we can't break it down, that's why I always recommend to patients, even with the supplements, to take it with a meal, because a meal will have sufficient amount of fat, and that helps you. So what you have to do in order to use a carotenoid, it has to go into what we call a micelle, or ideally a micromicelle, which is basically, I call this like a Pac-Man again. And it's this little package that puts itself around the carotenoid because we want to get it through the intestinal wall. And in order to do that, it has to be taken there through this kind of transporter, if you like. So it's packaged. And if it's all too clunked together, it's not going to be able to be taken by the micelle. So what are the micelles? You've heard of bile and surfactants. So our pancreas, we produce this naturally just by being alive, and foods that we consume help us do that. So the biology of our stomach is quite interesting. So that even the technology with our own science has been able to enhance the delivery system by providing these in micromicelle form with all the ingredients you like to send it on its journey. So it's really wonderful. But foods are really important, and we should promote them.
Protein?
Where? Yeah. I take protein myself. My PhD student is super fit. Gary, he plays hurling, and he's on the Waterford development squad and all of that, and he lives a perfect life, and he's eating so much protein and supplementing with protein. So I take some protein as a supplement myself. But I like foods that have protein, you know. I'm not against eating meat. I'm a nutritional plant biologist, but my favorite meal involves a steak. And
What about fish, John?
yeah, I love fish. My wife is allergic to fish, so we don't cook it at home. So it's my go-to when I'm out. Yeah. But again,
How bad are ultra processed foods?
very bad. But they're in my house.
Well, they're in everybody's house.
They're in my house. They're really bad because they're addictive. They give you your sugar hits. They'll spike your insulin, and then you'll crash, and then your body is saying, gather the fat. I do it myself. You know, I don't live a perfect life. I consume ultra processed foods, not a lot, but I do. I'd like to do better myself, but they're not giving us anything we need.
So you're saying there's no nutritional value, really?
None that I'm aware of, you know?
Yeah. Because one of the problems with, I mean, and we discussed this before the podcast, right, is there are competing narratives. And
Yeah.
some narratives are studies are supported by industry,
Yeah.
which, you know, one day you might listen to a podcast and meat is protein is great. And then somebody else, the vegan organization of America is supporting a study that says, no, meat is terrible. And there are all these competing narratives, and it's really difficult to parse out, you know, where we should get our information from, the authentic sources of the research. Like, let me ask you about, for example, blue zones. What's your perspective on blue zones? Is there a competing narrative there, or is it all? Should we all be living their Mediterranean diet, or in Japan, or what's your perspective?
Oh, the Blue Zone. I watched the recent Netflix one. I'm not sure if you watched. I know that guy. You know, the sad thing about that is that's being over commercialized right now. The Blue Zone thing, you can buy a Blue Zone cap. You know, so someone's benefiting. I think I know who. But anyway, the concepts and the elements of what are presented in the Blue Zone, you know, have someone that loves you, work in your garden, you know, dance, all these Mediterranean diet, they're all, you can't argue with them. I mean, they're the things that but back to my first point is can we improve systems to allow us operate within our own Blue Zone? That should be something we aim to do, but it's really not representative of the world. And I'd like to say that I accept where we are with processed foods, and, you know, I like a glass of wine myself, so I'm not going to sit on this podcast.
I was going to ask you about alcohol, right?
Yeah.
So we're not ruling out alcohol completely, are we?
I'm not, anyway. I like it too much. It's my reward at the end of the week. No, the Mediterranean diet suggests you can have some red wine.
Red wine.
Yeah. But again, you can do too much of anything, right? So I think the life balance is really what we try to go to. And within a 7-day environment, for me, I get it really good and I get it really bad myself. I want to be crucially honest with you. You know, before I came on this podcast, I did my Apple Fitness thing for half an hour because it's, you know, I like it. It's effective. I feel better. I have my endorphins. I want to eat better, all of that, you know, but I've my father-in-law's party here on Saturday night. I'm sure I'll have a glass of wine, maybe even a whiskey. Right. So, you know, that's just me being honest. I'm not going to be on your podcast and tell people to live in a blue zone totally, because I don't think we can comply to that. I think we need to do better and we should strive towards it. But I think we shouldn't be blinded to opportunities that are there to use targeted, safe nutritional intervention. And I really like your point, Connor, about, well, what do you believe now? Because, the link between industries, and look, our university is supported by industries to do work. But I think once you manage that, and that's why we have technology transfer offices and that's why we have IRB ethics departments, and that's why you have to do all your disclosures. And once you do all that, I think that's okay, because research needs support to function. I'm a big believer in proper peer-reviewed science. We have a new challenge, and not to overcomplicate it, but back in my day, when you published a paper, it meant something. And you probably spent a year trying to publish the work after it was done, where you were going through revisions. Now we have this thing called what I call a predatory journal, which are these commercial journals that have a high impact factor. So, so industries will put pressure on scientists to publish in those predatory journals, and they publish anything. So peer-reviewed science, unfortunately, is becoming contaminated too. But there are, within any field, I think experience as well. The one thing I'd say about our own field is there's patients have the best validation of our science is not the dissertations behind me or the 117 publications that we have. It's the results that we see patients getting and have been getting. And that makes me really happy. That's more important than anything.
What's coming down the track that you're excited by in the world of nutrition?
So for me, there's a couple of things coming that I'm really excited by. You mentioned sleep already, and the link with nutrition and sleep and lifestyle. That's really interesting. Cardiometabolic disease for me is an area that I'll probably focus on into the future. I'm going to be I'm very interested in sports as well. I've gone straight to the diseases, dementia, Alzheimer's, but my passion has always been sport. When I
High
told you,
performance
high performance, yeah, I love it. But one of the challenges and the opportunities coming down the line, if I stay very narrow in my own interests, are positively communicating with, working with, educating regulatory bodies to allow you, your listeners, patients, my own mom, know that product A is the right one to take, because, and this is the point, right now, if you and I went into a health food store to buy a carotenoid, we could probably buy one of 50 carotenoid supplements. I will tell you that 70% of those carotenoid supplements
will
not have active material that you're paying for.
Yeah.
Now, for full disclosure, I want to tell you this. I own no supplement. I give away my intellectual property to the university. They own it, and then they license it to organizations. They've done that, and that's great, and I have no problem with that. I have a great job. But what I do own, what I have created, is something called Supplement Certified, which is what we call a campus company, which is still owned by the university in part. But myself and another scientist saw this problem. About 5 years ago, we were blown away by our own data that when we analyze a supplement that the label says has 10 milligrams of lutein and it doesn't. How can that happen? So we basically set up a system called Supplement Certified, our program called Supplement Certified. And right now that program is for carotenoids, omega-3s, because that's where our technology is. So we spent years working to get that process ISO approved. So it was totally independent, bona fide. But I'm excited about this, Connor, because it's needed. And if I'm going to be on podcasts like this and going around the world lecturing and doing whatever I do and telling people, here's what we should be doing, I never imagined that my biggest challenge for that to be successful was that the quality piece was going to be passed or failed upon. So, and I've spoken to the Food Safety Authority of Ireland and Health Canada and lots of people about this, and about putting pressure back on the industries to have a quality piece. Because right now, you and I could not just go and buy a supplement, you and I could set up a company. and we could source material and we could put it in a capsule and we could say we could follow the labeling laws, which is really where, and the Food Safety Authority of Ireland didn't like that I said this, because I was on Claire McKenna's show, on her nutrition show, and I said this, and I got a phone call from them the day after, which was interesting. But I said, you may do a great job with process and labeling and making sure people don't put false claims, but who's testing this?
Yeah, and this is the thing, as you were talking about macular degeneration and explaining the science, I was thinking about running out and getting my carotenoid supplements. But then you hit me with the bombshell. 70% of those supplements, when I go into the store, and this is just, I'm presuming this is just in Ireland, are, I mean, they're placebos, basically.
Yeah.
There's nothing there. So imagine what's going on in the US, imagine what's going on. I mean, surely the European Union have some kind of measures to...
There's this thing, no. So all regulatory, I'm so happy you asked this, because all regulatory around food supplements is connected to labeling. It's not collected to analytical testing. And remember where I said this comes from? A field in Mexico. And it gets harvested. It gets processed. We do this thing called saponification, which is get rid of everything, cook it basically. You're left with lutein, zeaxanthin, meso, and then that's put into an oil, ideally an omega oil or a sunflower oil, something like that. And then it's weighed and it gets into a capsule. And they get it wrong. And so that's why, like, I mean, some companies don't get it wrong. Like, we work with companies now all over the world that are supplement certified. You know, the company we work with through our university, I mean, are you happy for me to mention, or will you?
Yeah, I mean, I think it's, I mean, you can substantiate, and there's evidence based, right?
So the company in Ireland and Europe that have commercialized the science that we have, and for the vision stuff, it's called Macuprime.
Macuprime, okay.
Yeah, Macuprime, Macuprime. And then for the Alzheimer's, because it contains the omega and the vitamin E, that's called Remind. That's called Remind, which was the name of the study. And again, I don't own those supplements. You know, I support those organizations. Of course I do, because I support, and I said to a podcaster only the other day, because we were talking about some issues with what some people were saying. And I said there's 3 types of science. There's science that just doesn't exist, and people are selling whatever they want because they can sell, and that's what they're doing. And then there's science where people say, well, we know compound X is good, so I'm going to make a product with compound X in it, and I'm going to do my best, and that might be fine. And then there's category A science, which is like what Macuprime and Remind have done, which is, you know, this has been on a 25-year journey to get to where it is. And by hook or by crook, and in partnership with the university, they've been able to license that, give money back to the university. There's a royalty going back to the university, support research. But the one thing I will say about all of our research is that it is run totally independent of the commercial organizations. I'd say about 60 to 70% of our funding has come from government, so competitive research grants. Industry has supported, donors have supported, philanthropy has supported, the original one being My Authority. That was donation, essentially. So there are all of the above. But all of the research is done by a scientist like me and my colleagues designing the protocol. We want to improve vision in macular degeneration. How are we going to do it? We work with a statistician. We design the experiment. We see how many people we need to have a likely effect. You know, because it's an ethical obligation to run a study that you're likely to win with, that you want to win. That's your, you know, you may fail, but you want to win. Are your measures sensitive enough to do what they are? And then all the data comes into a system. Codes are only broken at the end of the experiment. Statisticians do the analysis, and we report what we find. And we've had so many null negative findings that we thought we were going, but we have enough of the really good ones to make a difference.
Where can people find you? Where's the, you have a website? So
I'm on profjohnnolan.com. All of the points that I discussed with you today are based on published science, and I think there's 117 papers on my website now that are our own, and they're not just white papers, they're scientific publications.
Good, because I think I will include links to lots and lots of stuff and everything, but I think people will be excited by what we've been discussing in relation to carotenoids and supplements and authenticating
that's
the,
cool.
the right ones to use, right? Last question. I know we're running up on time here. AI, anything exciting you in the world of AI? Of what's coming? Have you looked at that space at all? Is there anything?
Yeah, well, I've had to because I have students. But your question is not about that type of AI. It's probably about how we use it in science. Yes. So when you look at the most exciting thing I've seen coming, and what I'll probably use is we're about to do a program in care homes supported by the NCBI, National Council for the Blind, or Vision Ireland. And we're starting that project in September. So we'll be going into care homes to do basic vision tests to see if there's simple things we can do, maybe spectacles, or maybe it's macular degeneration, or maybe whatever we see. Are there interventions we can do to allow people to live happier in their time in those care homes? And that's the goal of that experiment, right? But the AI piece is we will be able to image the back of the eye, and AI will do work for us by characterizing actually where that retina is in terms of disease. So it'll use all the data that's available to it to really focus our knowledge and outputs. Now, again, I have to learn this with the people that are giving us the technology, but that's something I'm alerted to. But I'm very open to it. I'm very cautious of it too, particularly in research. We can't stop human beings thinking like scientists. They have to any researchers listening to this that are on their journey, we have a rule now in our lab that we don't use any, in the writing piece, we don't use ChatGPT or any, it's forbidding to do because I want to see mistakes. I want to see students show me what they know and show me what they don't know, because that's where they can find their strengths. And that's where they can go on their own journey of excellence.
Policing that could be problematic or challenging, I would imagine, but
Yeah, we have tools now where we check.
Ah, very good, very good.
Oh,
Fantastic.
yeah, as a professor now, I never thought I'd have to, but I have to check scripts, I have to check reports, and
very interesting.
AI helps us catch AI. Very
good. Professor John Nolan, I wish you every success with that. The interventions in the care homes and stuff, I really do.
Thank
and your work is really inspiring. I'm going to run out and buy myself a bucket of carotenoid supplements. Thank you so much. I really appreciate it.